we are going to solve a question from continuity and differentiability chapter. Okay, so a function is given. They are asking whether the function has right hand derivative at 0, and option B, C, D contains continuity and differentiability of phi dash x, not phi of x. So first thing is at 0 whether the function is continuous or not. That's the first thing we need to check. Okay, because we know that if a function is discontinuous at a point, then automatically it is non-differentiable at that point. So first let us check whether phi of x is continuous at 0 or not. For that, what is phi of 0? Phi of 0 is 0. Now what we need to find? Limit at 0. So let me find limit x tends to 0, x square sine 1 by x. This is the function. When x tends to 0 means x is not 0. So I have to take the case where the x is not 0. Now when I substitute, what I am getting? 0 into sine infinity. 0 into sine infinity I will get. So 0 into sine infinity means 0 into value oscillating between minus 1 and 1. So its product will be definitely 0. So what you can say? Phi of 0 and limit x tends to 0, phi of x, both are same. So we can say that phi of x is continuous at x equal to 0. Now what is the next step? We need to check the differentiability of this function. Okay, so let us find phi dash x. So in order to find phi dash x at 0, I should go with RHD as well as LHD. So let me find RHD, phi dash 0 plus. Also in option A they have given phi of x has a right hand derivative at x equal to 0. So let us find phi dash 0 plus. So which will be limit h tends to 0, phi of 0 plus h, f of a plus h minus f of a divided by h. So that's the basic definition. Those students who doesn't know, I will just write the formula. Right hand derivative of a function at a is limit h tends to 0, f of a plus h minus f of a divided by h. Okay, so here at 0 we need to find right hand derivative. So instead of a it is 0. So I hope it's clear to you. Now let me write this. Limit h tends to 0, phi of h. What is phi of x? X square sine 1 by x. So what is phi of h? H square sine 1 by h. Now phi of 0, we already know phi of 0 is 0. So no need to write it, divided by h. Okay. Now, so this will be equal to limit h tends to 0, 1h will cancel. So you will get this. This is also same as 0 into sine infinity, which is again 0. Actually writing sine infinity is not a proper method, proper way, but still I am writing for our own understanding. That's it. Okay, this is objective paper, so for our understanding I have written sine infinity. So RHD we got, which is 0. Similarly, let me find LHD. LHD will be limit h tends to 0, phi of, earlier it was f of a plus h, here it will be f of a minus h minus f of a divided by minus h. F dash a minus, this is left hand derivative, which is limit h tends to 0, f of a minus h minus f of a by minus h. That's the LHD. So I have used that formula here. Limit h tends to 0, phi of minus h. Phi of minus h will be h square sine 1 by minus h. Here also minus h is there. It will be square, that's why I didn't write. Okay, minus h square minus 0 divided by minus h. Okay. So what it will be? It will be limit h tends to 0. Here h square and h will cancel. Sin 1 by minus h, I can take minus outside. Sin minus x is minus sin x. Both minus will cancel. So it will be again h sin 1 by h. Similar to the previous one. So what we got, RHD at 0 is equal to LHD at 0, which is equal to 0. So what you can say is phi of 0, phi dash 0 exists. That means function is phi of x is differentiable at x equal to 0. So that we got. So far which option is correct? Option A is correct. Now they are asking about phi dash x. Phi dash x is discontinuous, phi dash x is continuous. So what we need to understand is derivative of a function is also a function. So we will find phi dash x now. Okay, it is clear that phi dash x is defined. Phi dash x is a function which is defined at 0. And what is phi dash 0 value? 0. So you treat phi dash just like another function, just like f. Okay, so f of x is defined at 0 and f of 0 is 0. Similarly, phi dash x is a function which is defined at 0 and phi dash 0 is 0. Now what is phi dash x? Let us find phi dash x. Okay, so when x is 0, it is 0. That we understood. So when x not equal to 0, what will be phi dash x? How to find it? Because they have given this part. Phi of x is x square sin 1 by x when x not equal to 0. So when x not equal to 0, what will be derivative? Differentiate it. You should use UV rule. So 2x, x square derivative is 2x into sin 1 by x plus x square into derivative of sin 1 by x is cos 1 by x into derivative of 1 by x is minus 1 by x square. So when x not equal to 0, we got phi dash x, which is 2x sin 1 by x minus cos 1 by x when x not equal to 0. When x 0, it will be 0. So this is your new function. Okay, treat it like a new function. This is a new function. Okay, just like f of x, g of x, treat this as a new function. Now we will solve, we will check whether option B is correct. So they are asking, they are telling phi dash x is discontinuous at x equal to 0. So what is phi dash 0? Phi dash 0 is 0. That we got it very easy, which is derivative of phi of x at 0. Now what we need is whether it is continuous. For that I should find limit. So limit x tends to 0, phi dash x I need to find. Okay, I am not finding LHL and RHL. Directly I am going for limit at 0. We will see what we are getting. So when I substitute what I am getting here, I am getting 2, 0, then sine 1 by 0. 1 by 0 can be either plus infinity or minus infinity. Okay. So, okay. For more clarity, let me take RHL then, no problem. Okay. Then it will be plus infinity minus cos plus infinity. 1 by 0 plus will be infinity. So what we got is 2 into 0 into sin infinity. 0 into sin infinity will be again 0. Previously we did that. So it will be 0 minus cos infinity. What is cos infinity? Value oscillating between minus 1 and 1. So limit exists, limit does not exist. This limit does not exist. Why? Because it is oscillating between minus 1 to 1. So RHL of function does not exist. Similarly, LHL will not exist. So what I can say, limit x tends to 0, phi dash x does not exist. Okay, LHL also similarly you will get. Instead of infinity, it will be minus infinity. Sine minus infinity, cos minus infinity. Same explanation we can use. So what we can say is limit x tends to 0, phi dash x does not exist. So phi dash x is discontinuous at x equal to 0. Phi dash x is discontinuous at x equal to 0. If phi dash x is discontinuous at a point, then automatically phi dash x is non-differentiable at 0. So option B is correct, option B correct, option A correct, option B correct, option C wrong, option D also wrong. Okay, so that's it.